to this point, we have done Boyle's Law, Charles' Law, Gay-Lussac's Law. What we're going to be doing next is putting all three of these together. So if you look, they share at least one of the three variables: pressure, volume, and temperature. So if we combine all three of them, which unfortunately I put at the bottom of your worksheet, the combined gas law, we're going to have P1 V1 over T1 equals P2 V2 over T2. So you would use this when all three of your variables are changing. So that only leaves one variable left that doesn't change, and that is if you have the same sample of gas or the amount of gas. Okay. And again, this is going to be a two-condition law. So again, you have to decide what variables are changing so you know which rule to apply. Okay. On the Combined Gas Laws worksheet, because of formatting this in Google Docs, I wasn't able to get the subscripts and the line in, so you're going to have to add this line to divide P2 V2 from T1 and T2. Again, all of this information should be on your blue gas laws summary sheet, but I just wanted to have this all in front of you so you didn't have all of it at once. So again, as you're looking through this, you want to look at what volume of gas occupy at 2.5 ATM. Okay, oops. Okay, since ATM is a pressure unit, okay, this is going to be my P1, and at 30 degrees, that's a temperature, so this is going to be T1. Now, if you read ahead, if the initial conditions were 1.5 ATM, 3.0 liters, and 20.0 degrees Celsius, those really are your initial is usually first, but since I already assigned these first two as P1, T1, I'm going to assign these as P2, V2, and T2. Again, as long as the conditions that go together have the same numbers, that's all that matters. So these are a little more cumbersome in terms of the numbers. So P1 V1 over T1 equals P2 V2 over T2. If you look, this is what I'm finding is volume 1. So this is the thing that I'm going to need to keep together. So I usually rearrange the letters and then put the numbers in, but there's no right or wrong way to do this. So I'm going to do the algebra, so I'm going to cross multiply, or you could multiply by the reciprocal, again, as long as your algebra units are correct. V1 is going to equal P2 times V2 times T1, and again, remember, temperature is going to be in Kelvin every time we use it in an equation. And then P1 and T2 are going to end up on the bottom. Okay. So here, then, I'm just plugging in my numbers, so I have all my math in one place. So my P2 is 1.5 ATM. My V2 is 3.0 liters. And my T2 is going to be 20 plus 273. And again, we could put the 1.5 in for that one, so that makes that one a little more accurate. And then divided by my initial pressure, which is 2.5 ATMs, and my initial temperature, which is going to be 30 plus my 273.15. Okay, so you'll see your units cancel ATMs. Okay, these will both be K, so they'll cancel. And if you want to go ahead and do your temperature values, okay, this would be 293, okay, 0.2 K, and this one's going to be 303.2 K. Okay. So when I plug those numbers into my calculator, I'm only allowed 2 sig figs because of all of these numbers only being to 2, so V1 equals 1.9 liters. So I'm going to show this setup with the numbers substituted in first. You can decide which one you like, and it doesn't matter, whichever method works, as long as you're using correct substitution, so you're keeping the right things together, and you are converting units to the same thing, converting your temperatures to Kelvin. Either method will get you the correct answer. I just like having all of the math done kind of ahead of time, and then I can just substitute in my units. Okay. And again, if you don't like the method of cross multiplying, you could multiply by the reciprocal here. So again, what I have here in green is the minimum amount of work that you need to show if you're not doing it the other way with rearranging the letters and then substituting the numbers in. Okay, in this problem, gas is initially at 650 torr, so torr is a pressure, so that's going to be P1. 100 degrees Celsius is going to be a temperature, so that's T1, and it's heated to 150 degrees Celsius, so this is a second temperature, so I'm going to have T2. At 1.8 atm, so atm is a unit of pressure, so that's P2. So notice your pressure units don't match. That's something we'll need to think about later in the problem. Changes to a volume of 225 milliliters. So again, all of these 150, 1.8, and 225 are connected to the same condition, so that's going to be V2. Initial volume is what I don't know, so V1 is what we aren't going to know. So I'm going to solve by rearranging the equation, just like I started the other one with. So going to P1 V1 over T1 equals P2 V2. So V1, again, is what I don't know, so I'm going to rearrange this equation. So I'm going to have my cross multiplication and my cross multiplication. So I'm going to have P1 V1 T2 equals P2 V2 and T1. And again, V1 is what I'm trying to solve, so I'm going to divide both sides by P1 and P2. Okay, and those guys will cancel, and then I'm ready to substitute numbers in. So V1 is going to equal my P2, which is 1.8 atm, and it's always easier to do these things on the top, so I'm going to do my conversion to torr here. So 1 atm is 760 torr. Okay, so that's my pressure conversion. My V2 is 225 milliliters. And my T1 is 100 plus 273. Now, again, not a whole lot of sig figs on that one, so that's going to be 373 Kelvin, divided by my P1, which is 650 torr. So again, if I go back up here, my ATMs cancel when I do that bridge problem, and now my torrs will cancel. And times T2, which is 150 plus 273. Again, I'm not worrying about the 0.15 since the 150 is not very accurate, but that's going to give me 423 Kelvin. So you'll see that my Kelvins cancel, and then I'm ready to solve for volume. Okay, again, the calculator is going to give you this long answer of 415 point something, but the 100 actually only allows you to have one sig fig, so this is going to be about a volume of 400 milliliters. So remember, any non-zero digits count for sig figs, and you're going to fill in zeros just to hold place values, so I wouldn't do 400.00 because then those would be significant if they're not necessary to keep the number.